Students, do you know how thrilled I am to be making this video on break? Probably not as thrilled as you are to be watching this video on break. So thank you for watching, if indeed you are watching over break. Otherwise, whatever, thanks for watching. We're dealing today with section 3.4. Today we're going to solve equations, and the variable is going to be on both sides of the equations, and you'll see what I mean in just a couple seconds. The essential question for today, there are two. First of all, what strategies can I use to combine like terms when there are variables on two sides of an equation? That's what we're going to start with. And then at the end of the video, I'm going to show you two types of equations. One of them is going to result in a no solution, and one of them is going to result in this sort of thing where x could actually be any real number, like x could be any solution. So that's interesting. I'll show you what those look like. First of all, though, let's start with a more traditional type equation. Here's example 1. Notice that there are a couple things going on. I have parentheses here. The big feature, though, is that I have a d here and I have a d here. Now, that's trouble, because remember, my ultimate goal of solving equations is that I need to have just one d on one side of the equation. If I have a d over here and then I have like 3 minus d over here, well, I haven't solved the equation yet. There's still a d on both sides. So I need to figure out a way to get these d's together. Before we do that, though, let's just take care of the parentheses. Distributing this 3 in is going to eliminate the parentheses and just help me get my d's together. So I have 3d plus 12 equals 8 minus 4d. And remember, it's important to do because right now, if I wanted to eliminate the 12 outside of the parentheses from the first step, I wouldn't be able to because, well, it's trapped in parentheses. And actually, since I showed that, it helps me realize that, did I do 3 times 12? Nope, I just rewrote 12. So 3 times 12 is actually 36. Good. And now the parentheses are gone, and so I can eliminate things from both sides. These are also problems where you're going to want to definitely draw that line through, because I really need to know, hey, there's a d on this side and there's a d on this side, and they can't just randomly switch sides. So in order to get the d's together, I'll just show you the trick, and then we'll practice using it later on in equations. I want the d's to be off of this side, and I want them to be over on this side. So let's just do this. I'm going to add 4d to this side. Isn't negative 4d plus 4d, doesn't that cancel? And that's great, because now I'm only left with 8 on this side. I no longer have the d's over there. But, of course, what I do to one side of the equation, I must do to the other side. So if I added 4d to the right, I also need to add 4d to the left. And I'm going to add it only to the 3d because it's combining like terms, right? It doesn't make sense to add 4d here because 36 and 4d, they're not like terms. So 3d plus 4d is 7d plus 36. Now, because I canceled the d's from this side, they are all together on this side, and it's just a conventional equation. Let's solve by subtracting 36 from both sides. So cancels, I'm left with 7d equals negative 28. And dividing through by 7 cancels, I'm left with d equals negative 4. Voila. Next problem, it's a square problem. Every time I see a shape, I just want to draw a little smiley face in the middle. That makes me think that word problems are less evil. And this kind of almost looks like the reverse of the Moroccan flag, right? Green with red instead of red with green. Anyway, the point is, for this problem, I need to solve for the perimeter of the square. Now, right now, I don't know anything about the perimeter of the square, and they really only give me two sides. I could put 3x plus 7 here and 4x minus 2 here, but don't I know something about a square that's important? What do I know about a square? Oh, I know that all of the sides are equal. So since all the sides are equal, wouldn't you say that this 3x plus 7 is equal to this 4x minus 2? Hey, let's make that an equation and solve for it. So 4x minus 2 actually equals 3x plus 7. Why? Because all the sides of a square are equal. Okay, at this point, let's draw that line through, keep us nice and organized. I have x's on two sides of the equation. I hate it. I hate it more than I hate I don't know, racism or something. So at this point, I need to get rid of the x's here. So I'm just going to cancel them. Just subtract 3x. Okay, they're canceled, they're gone. I'm left with just 7. But wait, if I canceled the 3x there by subtracting 3x, I also need to subtract 3x from this side. That gives me, oh, just 1x. That's nice. Minus 2. 4 minus 3 is 1x. Okay, and then I can add 2 to both sides so that x equals 9. Now, I'm not quite done because they're actually asking what is the perimeter of the square. So in order to take that x and actually use it to find the perimeter of the square, let's just plug it back in here. So 3 times 9 plus 7. 3 times 9 is 27, and 27 plus 7 is 34. And since this side is 34, I also know that this side is 34, and this side is 34, and this side is 34. Why? Because it's a square. In other words, for the perimeter, I'm doing 34 times 4, because there are 4 of them, and that's going to happen to equal 136. Great, perimeter of the square. Now, as I promised, we have 2 wacky examples. One of these examples is going to result in a no solution. One of them is going to result in all real numbers. Are you enticed? I'm enticed. Let's see what is what. So let's solve this first problem. Again, I can start probably by distributing in. That would be 8x plus 4 equals 8x. And now take a look at what I have going on here. I do not want the 8x to be here. So I'm going to subtract it. So canceling the 8x, that leaves me with just 4 on that side. But look what happens when I also subtract 8x on the other side to keep my equation balanced. I'm left with 0x. And what's 0 times x? Isn't 0 times x just 0? Because 0 times anything is 0. So this 0x, I'm going to write as just 0. So where's the variable? Like, remember how my final goal is to have x equals something? Well, now there's no x in the problem at all. How can I reach that goal? And it turns out I can't. So I have to stop at this step, and I just have to think to myself, does 0 equal 4? Does that make sense? Can you have 0 apples and that's the same thing as having 4 apples? Definitely not. This is a nonsensical statement. This is a false statement. So what this means here is this. When I was solving the equation, the x's got canceled, and I was left with a false statement. That means that any x I plug in for, no matter what x I try, it will always end up being no solution. So let me just show you one example of what I'm trying to say. I'm going to pick any random x, and it won't work. And you can prove it to yourself by picking other x's. For example, let's just plug in 1. I'm going to plug 1 in for every x. Okay, so on the right-hand side, I have 8. Sorry, on the left-hand side, I have 8. 8 times 1 is 8. On the left-hand side, I'll do the parentheses first. 2 times 1 is 2, plus 3 is 3. 3 times 4 is, because I'm multiplying the parentheses times the 4, 3 times 4 is 12. Yeah, that's a false statement. Looks like when I plugged in something for x, it didn't actually make the equation work. So that's what I'm talking about. Literally, and you can test this yourself, literally everything I plug in for x will never end up making the equation work. It'll always be something like that, 8 equals 12, some false statement. Let's look, though, at this next one. So this next equation, I'll distribute in. They're very similar equations, so 8x plus 4, 8x plus 4. Okay, I hate the 8x's over here, so I'm going to cancel them, and I'll be left with just 4. But to keep the equation balanced over here, I also cancel, and the x's go away like they canceled, and I'm left with 4. So the variable canceled out. I can't keep solving. But look, now instead of having a false statement like in the previous example, don't I have a true statement here? Like 4 does equal 4. This is a true statement. So what that means for my solution is x could be any real number. X could be any real number. It could be the square root of 2. It could be pi. Doesn't matter. It will always make the equation true. Let's just try something. Somewhere out there in space, think of an x and try plugging it in. It will work. I'm going to just try plugging in 1. So on the right-hand side, I have 8 times 1, which is 8, plus 4, which is 12. On the left-hand side, remember we have to start in the parentheses. 2 times 1 is 2, plus 1 is 3, and then 3 times the 4 is going to be 12. Hey, I got a true statement. And so that means that 1 is a value of x that works. But literally anything else you plugged in for x would work as well. It would always give you a true statement. That's why I'm saying here that x could be any real number. So if the variable cancels and you're left with a false statement, no solution. X could not be anything. If the variable cancels and you're left with a true statement, x could be anything. Literally anything you plug in for x will make the equation work. Great. So summary, to get the x's together, simply cancel the x from one side. A true statement, so that's something like 0 equals 0, with no variable means x is any real number. A false statement, so something like 2 equals -7, with no variable means no solution. Thanks for watching, guys. Hope that made sense.